In this episode, we're going to look at how to subnet an IPv4 network. I'll show you how to do it and have a discussion about the concepts along the way. In this activity, we're going to subnet a customer network into several subnets. The subnet scheme should be based on the number of host computers required in each subnet, as well as other network considerations like future network host expansion. After we've created the subnetting scheme and completed the table by filling in the missing host and interface IP addresses, we'll then configure the host PCs, switches, and router interfaces. After the network devices and host PCs have been configured, we'll then use the ping command to test for network connectivity. Greetings to all my tech heads out there in the KevTechify nation, and if you're new here, welcome. This episode is part of my series on configuration examples for the CCNA. I'm Kevin here at KevTechify. Let's get this adventure started. Subnet and IPv4 network. I have the Packet Tracer lab already open. On the left side, we have our work area with all of our devices. Last part of the lab, we're going to go in there and configure them, put the addresses we're going to subnet here as we start off this lab. We're going to put them in there and get our network running. On the right side, bottom right, I have the original Packet Tracer activity window that gives us our information, but I mainly keep that open to use the check results right here. Then in the upper right here, I have the Word document. The Word document is basically what the Packet Tracer activity document is, but it allows me to fill in the fields. Partway through this, they're going to have us go in and fill in these fields with the subnets we did, and there's questions to answer. I can do that in the Word document. Now, here's our addressing table. You can see that's incomplete. We're going to, throughout this lab, we're going to go through and enter that information in. Here's our objectives and a background scenario. Coming into our instructions. Part 1, subnet the assigned network. Create a subnetting scheme that meets the required number of subnets and required number of hosts. Now, here are our requirements. A, we need a minimum of 50 hosts on LAN A. Second requirement, second subnet is LAN B. LAN B here is the bottom left of our network. You need a minimum of 40 hosts on that network. Minimum of 40 host IP addresses. C, you also need 2 additional unused subnets for future expansion. We're planning that our company is going to grow, you're making money, that we want to add more devices onto your network. That's what we're looking at. Answer the following questions. Create a subnetting scheme that meets the stated network requirements. First question, how many hosts are needed in the largest required subnet? We go back up to our requirements. This first subnet says we need 50 hosts. The second subnet, LAN B, that says we need 40. So our big number right here is 50 hosts. What is the minimum number of subnets required? Going back to our requirements, first subnet, that's 1. Second subnet, that's 2. We also need 2 additional. That gives us a total of 4. We have 2 required subnets, 2 future expansion subnets. That is a total of 4 subnets. There we go. The network you are tasked to subnet is the 192.168.0.0/24 network. What is the /24 subnet in binary? Once again, as we remember, what the slash number means here at the end of an address, that means how many bits are in the network portion. The network portion is the first part of an IPv4 address. IPv4 address is 32 bits long. That slash number will never be bigger than 32. And what it's saying is, out of those 32 bits, the first 24, that's the network portion. When we write out a subnet mask, the subnet mask in binary is all ones in the network portion. That is all ones in the network portion followed by all zeros. If the network portion here is 24, that means we have 24 ones in the network portion followed by 8 zeros. 32 minus 24, that gives us 8 left. 8 zeros left for the host portion. That will show us, and once again, the 32 bits, we're going to put it in octets. Every 8 bits, we're going to put a period. That just helps us as humans better read that. The answer to the question here, what is the subnet mask in binary for /24? 1 2 3 4 5 6 7 8 dot 1 2 3 4 5 6 7 8 dot 1 2 3 4 5 6 7 8 dot. So that takes care of our /24. And then we have to fill in the remainder, the host portion, with zeros, which are 8 zeros. 1 2 3 4 5 6 7 and 8. That is what our /24 subnet mask in binary looks like. The subnet mask is made up of 2 portions, the network portion and the host portion. This represents the binary by the ones and the zeros in the subnet mask. Question: in the network mask, what do the ones represent? So in our subnet mask, what do the ones represent? Well, the ones represent the network portion of the address. So ones represent the network portion. Next question. In the network mask, what do the zeros represent? The zeros represent the last part, the host portion. Represent the host portion. To subnet a network, bits from the host portion of the original network mask are changed into subnet bits. The number of subnet bits defines the network portion. The bits from the host portion of the original mask are changed into it. What this is saying is the host portion, the last part of that subnet mask, we're going to borrow some of those bits to create smaller networks on our network. The smaller networks allow us to better manage our networks. You have more control over how the network goes. It also goes to add in some security. Question: given each of the possible subnet masks depicted in the following binary format, how many subnets and how many hosts are created in each example? What we're going to do is we're going to use this information. They give us a /25. Once again, that /25 means there's 25 ones in the network portion, and then the rest is the host portion. Once again, remember, the IPv4 address is 32 bits long. We're having 25 of those 32 bits in our network portion. 32 minus 25, that equals 7. That's how many bits will be left in our host portion. Right here, we have the 7 bits in our host portion. They do give us a hint. Remember that the number of host bits to the power of 2, so 2 to the number of host bits, defines the number of hosts per subnet minus 2. Minus 2, once again, is you can't use the first IP address because that's a network address. You can't use you can't use the last IP address because that's the broadcast address. The second nugget they throw at us here, the number of subnet bits to the power of 2. So 2 to the number of subnet bits, that's the number of bits we're borrowing, defines the number of subnets. The subnet bits are shown in black. Right here, they're shown in bold, are the bits that have been borrowed beyond the original network mask of 24. Okay, let's go down, let's work through this. The first one they're asking us to do is a /25. /25 is the first 25 bits of our 32-bit IP address is the network portion. The remaining 1, 2, 3, 4, 5, 6, 7, or 32 bits minus 25 bits, that gives us 7, is our host portion. What is the dotted decimal subnet mask equivalent of this subnet mask? Once again, subnet masks always follow all ones, which represents the network portion, followed by all zeros. That represents the host portion. All ones followed by all zeros. What's the dotted decimal? No. What is the dotted subnet mask equivalent of this binary right here? Well, we have 8 ones in the first octet. 8 ones represents 255, so that gives us 255. Second octet here again is all ones, that gives us another 255. The third one gives us all 255s. I'm going to go ahead and type that in there. 255, 255.255 dot, and then this last one here, 1 followed by 7 zeros. Now we go back and remember the conversion technique. We look at the value of the column. If there's a 1 there, we add those all up where there's 1s. Starting here, the value of this column is 1, this is 2, this is 4, 8, 16, 32, 64. The value of this last column here is 128. There's only a 1 in the 128 column. Add that all up, 128, and that's it. That gives us our dotted decimal subnet mask equivalent right there. Number of subnets. They're asking us for the number of subnets. We will go up here. We will look at the second little nugget they threw at us. The number of subnets is the number of subnet bits to the power of 2. So 2 to the power of the number of bits, subnet bits. We're only borrowing 1 bit, so that's 2 to the first power. Any number to the first power is the number itself. So 2 to the first power, any number to the first power is that number itself. 2 to the first power is 2, and that is 2 subnets. There. Next part, number of hosts. Number of hosts, look at the first little nugget they threw at us, is the number of host bits, 2 to the power of number of host bits, define the number of hosts per subnet minus 2. Once again, we have the minus 2 because we cannot use the first one. The first one is the network address. Can't use the can't use the last one. That's the broadcast address. Our formula here is 2 to the number of bits in the host portion. That's our zeros here. We got 1, 2, 3, 4, 5, 6, and 7. And then we subtract 2 from that. Can't put a minus 2 here. We got to make sure we put our parentheses in here. That way we do 2 to the 7th first, get that number, and then we subtract 2 to that. Now 2 to the 7th, that is equivalent to 2 times 2 times 2 times 2 times 2 times 2 times 2. Should be 7 2s in there. Get that number and you subtract 2 from that. 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32, times 2 is 64, times 2 is 128. 128 minus 2, that gives us 126. 126 hosts, and that is per subnet. So each subnet can have up to 126 hosts. Once again, it's not 128 because you can't use the first one. The first one's a network address. You can't use the last one. The last one's a broadcast address. That gives us a total of 126 usable IP addresses per subnet. And once again, we have 2 subnets. So each one of those 2 subnets, 126 hosts per subnet. Okay, that takes care of our /25 address. Let's go and do our /26 address. /26 once again means we have 26 bits in the network portion. 8 plus 8 plus 8. 8 plus 8 is 16, plus 8 is 24, 25, 26. That means we are borrowing 2 bits from our original /24. First question is what is the dotted decimal, what is the dotted decimal subnet mask equivalent? Okay, let's go ahead, take the first 8 bits. First 8 bits are all ones. Whoops. First 8 bits are all ones. Your second octet is 8 ones again, 255. Third octet is all ones, 255 dot. And then we have a 1 in the 128 column, we have a 1 in the 64 column, and no other one. So 128 plus 64, that gives us 192. Number of subnets for our /26 subnet. Number of subnets is 2 to the number of bits we are borrowing. We are borrowing 2 to the second power, or 2 squared. That is equivalent to 2 times 2, which is 4. And once again, that is subnets. We have to figure out the number of hosts. Number of hosts, once again, we start off putting in parentheses 2 to the number of bits in the host portion. We take what's left, what's the zeros. That gives us 1, 2, 3, 4, 5, and 6 bits in our host portion. So 2 to the 6th. And we subtract 2 from that total because you can't use the first one. Network address, can't use the last one. Broadcast address. That is equal to 2 times 2 times 2 times 2 times 2 times 2, 6 2's. And you subtract 2 from that total, which is equal to 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32, times 2 is 64. 64 minus 2, that gives us 62 hosts per subnet. We got 4 subnets. Each one of those subnets can have a maximum of 62 hosts per subnet. Onto our /27 network. /27 means 27 bits in the network portion. 8 plus 8 is 16, plus 8 is 24, 25, 26, 27. That gives us, we are borrowing 3 bits from our original /24 for our /27. What is the dotted decimal notation? First octet is all ones, 255. Second octet is all ones, 255. Third octet, once again, is all ones. And then we have 128 plus 64 plus 32. That gives us 128 plus 64 plus 32 gives us 224. Number of subnets for our /27 network. 2 to the number of bits that we are borrowing. We are borrowing 3 of them. That is equal to 2 times 2 times 2, which is 2 times 2 is 4, times 2 is 8. That gives us 8 subnets. Number of hosts. 2 to the number of bits in the host portion. That's what we have left over. Those are our zeros. We have 5 zeros there. So 2 to the 5th. And we got to take 2 away because you can't use the first one, can't use the last one. That is equal to 2 times 2 times 2 times 2 times 2, 5 2's. Subtract 2 from that total. That gives us 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32. 32 minus 2 for a grand total of 30 hosts per subnet. Our /27 gives us 8 subnets. Each one of those subnets has 30 hosts per subnet. /28 network. /28. 28 ones in the network portion. 8 plus 8 is 16, plus 8 is 24, 25, 26, 27, 28. We are borrowing 8 bits from our original 24. Dotted decimal notation. First 3 octets are all ones. 255, 255, 255. Dot. And then we look at 128 plus 64 plus 32 plus 16. If you add all those up, once again, 128 plus 64 plus 32 plus 16. That gives us 240. Number of subnets. Number of subnets. 2 to the number of bits in the network portion. That's 2 to the 4th. That is equal to 2 times 2 times 2 times 2, which is equal to 2 times 2 is 4, times 2 is 8, times 2 is 16. That gives us 16 subnet masks. Number of hosts. 2 to the number of hosts, or number of bits in the host portion. Since we borrowed 4, that leaves us with 4 remaining, because we have 8 bits total. So that's 2 to the 4th. We subtract 2 from that total. That gives us 2 times 2 times 2 times 2, minus 2 from there. 2 times 2 is 4, times 2 is 8, times 2 is 16. 16 minus 2 gives us our total of 14 hosts per subnet. Our /28, once again here, gave us 16 subnets. Sorry about that. And each one of those 16 subnets can have up to 14 hosts per subnet. 14 valid IP addresses. /29 gives us 29 bits in our network portion. That gives us 5 bits we're borrowing from our original /24. Dotted decimal subnet mask equivalent. First 3 octets are all ones. 255, 255, 255. Takes us down to 128 plus 64 plus 32 plus 16 plus 8. If you add all of those together, that is 248. That is 248. Number of subnets. 2 to the number of bits we are borrowing in the network portion. We are borrowing 5 bits. 2 to the 5th, which is equal to 2 times 2 times 2 times 2 times 2. 5 2s. 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32. 32 subnets. 32 smaller networks in there if we borrow 5 bits. Number of hosts. That is 2 to the number of bits in the host portion. We borrowed 5. That gives us 3 remaining. 2 to the 3rd. Can't use the first one. Can't use the last one. So we subtract 2 off. That gives us 2 times 2 times 2 minus 2. 2 times 2 is 4. Times 2 is 8. 8 minus 2. That gives us 6 hosts per subnet. /29 gave us 32 subnets. Each one of those 32 subnets has 6 hosts per subnet. And down to our last one, a /30. /30 means there's 30 bits in the network portion. 30 bits from our original 24 bits. We are borrowing 6 bits. Dotted decimal subnet mask equivalent. First 3 octets are all ones. Then we go and we add up 128 plus 64 plus 32 plus 16 plus 8 plus 4. Add all those together. That gives us 252. Number of subnets. 2 to the number of bits in the network portion. Number of bits we are borrowing. We are borrowing 6. 2 to the 6, which is equal to 2 times 2 times 2 times 2 times 2 times 2. Or 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32, times 2 is 64. 64 subnets. Number of hosts, once again, 2 to the number of bits in the host portion. Since we borrowed 6 bits for our network portion, that leaves us with 2 bits in the host portion. So that's 2 to the second power, 2 squared. Subtract 2 because we can't use the first one, can't use the last one. That gives us 2 times 2 minus 2, which is 2 times 2 is 4. 4 minus 2. Final answer here is 2 hosts per subnet. Using a /30. /30 gives us 64 subnets we can create from that original /24. Each one of those 64 subnets can have a maximum of 2 hosts per subnet. Now, where would you use this? You would use this on point-to-point connections. Like a serial connection to a serial connection on a router would be a great example of where you would use something like this, because you can't have more than 2 IP addresses there. Question: considering your answers above, which subnet masks meet the required number of minimum host addresses? Well, we need to go remember what our minimum number of host addresses are and then see what subnet mask did that. Minimum number of hosts right here. How many host addresses are needed for the largest required subnet? That's 50. All subnets need to have at least 50 hosts, usable IP addresses there. Coming down here, our /25, that had 126 hosts. 126 is more than 50. /25 works. /26 has 62 hosts per subnet. 62 is more than 50. /26 works. /27 has 30. 30 is not more than 50. You need 50 hosts per subnet. That means the /27 won't work. /28 only has 14 hosts per subnet. We need 50, so /28 does not work. /29 has 6 hosts per subnet. Once again, we need 50. /29 will not work. /30 only has 2 hosts. We need 50. That does not work. That means only the first 2, the /25 with 126 and the /26 with 62. Those are the only 2 subnet masks that are going to work. /25, /26. /25 and /26 will meet the minimum required number of hosts per subnet. Next question. Considering your answers above, which subnet masks meet the minimum number of subnets required? Minimum number of networks. Well, let's go back up here. We answered a question that hopefully does that. What is the minimum number of subnets required? We had 2 required. We had 2 for future expansion. Gives us a total of 4 subnets. Our minimum number here is 4 subnets. Starting off with our /25. /25 has only 2 subnets. We need a minimum of 4. Does not work. /26. That has 4 subnets. That's a minimum of 4. So /26 works. /27, 8 subnets. /27 works. /28 has 16 subnets. Once again, minimum of 4. 16 is more than 4. /28 works. /29 has 32 subnets. That one works also. And /30 has 64 subnets. That one worked. They all work except for the /25. Our answer down here is /26, /27 /28 /29 and /30 meet the minimum required number of subnets. Third question of this group. Considering your answers above, which subnet mask meets both the required minimum number of hosts and the minimum number of subnets required? What we have to do is look at these two questions we just answered right here. Which subnet mask meets both of these requirements? If we look here, /25 does not appear in both of them, but /26, that appears. /26, definitely right there. /27 only appears down here. /28 only appears here. /29 and /30 only appear here. The one that meets both requirements is the /26. /26 will give you the 4 subnets that are required and 62 hosts per subnet, which is greater than the required 50 hosts per subnet. When you've determined which subnet mask meets all of the stated network requirements, that is this right here, derive each of the subnets. List the subnets from first to last in the table. Remember, the first subnet is this with the chosen subnet mask. Okay, the first subnet is 192.168.0.0. 192.168.0.0. The prefix we got here is the /26. The prefix is the same for all of these networks. We get a /26, /26, /26, and /26, and the subnet mask. If we go back up all the way to our /26, they had us figure out what the dotted decimal subnet mask equivalent is. That is 255.192. 3 255s and a 192. Once again, those are all going to stay the same for all the different subnets. That was 255.192. 192. 255.192. The subnet address is that first address of each of those 4 networks we came up with. Remember, we've divided, we said we're going to take this entire /24 network. This portion will stay the same in every address, but then we're going to divide this up into 4 locations. Because the /24 stays the same, we can't do anything with those first 24 bits. Those all stay the same. So 192.168.0. And then the octet there will be what we figure out. And all of these network portions for the /24 are going to be the same. All we have to do is figure out what this 4th octet is. What is the network address for each one of these? We divided this up into 4. If we go up to here, back to our /26, we can see that we're borrowing 2 bits. Borrowing these 2 bits, what we have to do is we need to figure out all the different possibilities. The different possibilities there are 00, 01, 10, and 11. What you do is you start off with 00 in those 2 bits we borrowed. Add 1 to that. 0, 0 plus 1, that gives you 0, 1. That's the start of our second network. Then, for the start of the third network, you add 1 to that. 0, 1 plus 1, 1 plus 1 equals 2, but we're in binary, you can't have a 2. What you do is you increment the next column, or the column to the left, and then you restart over. So 0 plus 1, or 0, 1 plus 1, that gives us 1, 0. That's the start of the third network. Then you add 1 to that, and you continue adding until you get all 1s. Right now we're at 1, 0. If you add 1 to that, that gives us 1, 1. We continue all the way down until we have all 1s there, which we do. That's the start of the fourth network. Once again, we had 0, 0, 0, 1, 1, 0, and 1, 1. All in this space right here. If we start off with 0, 0, that was our first network. That was 0. Come back down here. That's what we have. Now we got to figure out the start of the second network. Start of the second network was we had 0, 0. We added 1 to that. We add 1 to that. That gives us a 1 in this column right here. 1 in the 64 column. That's the only one we have. That gives us 64 there. The third network, once again, we have 0, 1, add 1 to that. Can't have a 2, so we increment the next column to the left, start over. That gives us a 1, 0. That gives us just a 1 in the 128 column. And that's it. Start of that network is 128. And the start of the fourth network. We are at 1, 0 here. Add 1 to 1, 0. That gives us 1, 1. That gives us a 1 in the 128 column and a 1 in the 1 in the 64 column. 128 plus 64, that gives us 192. These are the start of our networks, each of those individual networks. On to step 2, fill in the missing IP addresses in the addressing table. That's the table up at the top of this document. A, assign the first subnet to LAN A. If we look over here on the left side, LAN A is the upper left corner, signified by the name of the switch right here. This is LAN A. Use the first host address, the first usable address, so you can't use 0. You have to add 1 to that. 0 plus 1 gives us 1. Use the first host address for the customer. Once again, this is the network address. Can't use the first one, but if you add 1 to that, you can do that. Use the first host address for the customer router interface connected to LAN A. Okay, let's scroll back up here. We have customer router. Use the first IP address, 192.168.0. Network address was 0, but you can't use that one because that's the network address. You have to use the first usable address. That would be a .1. Our subnet mask. Oh, let's go down and see what the question is. Use the second host address for the LAN A switch. Now for the LAN A switch, what we want to do is use the second address. .1 was the first address, that went to the router. .2 is the second address, that's going to go to the LAN A switch. 192.168.0.2. Once again, our subnet masks for those was our /26 or .192, 255.255.255.192. Subnet mask stays the same for any device on that network. And our default gateway for LAN switch A. So our LAN switch A, default gateway once again is the exit off of our network. The exit off of our network and onto somebody else's network. The device that connects up multiple networks is a router. And so what we want is this IP address here up here and a couple lines above it, that's the gig 00 interface. We assign this address. That means the default gateway for LAN A switch here is the IP address of this gig 00 interface, 192.168.0.1. Use the last host address for PCA. Make sure to assign the default gateway. Okay, use the last host address. Well, the first address of the next network is 64. That means .63 would be on this network, but once again, you can't use the last address because that's the broadcast address. The last usable would be .62. .62. Okay, go up to our table here. PCA. Remember, .62, 192.168.0.62. Subnet mask stays the same. 255, 255, 255.192. And the default gateway, once again, our default gateway for this network is our exit off. It's this interface. It's the interface on customer router. It's the gig 00 interface. It's this IP address right here. Default gateway of 192.168.0.1. There we go. Okay, we took care of A here. On to B. Assign the second subnet, and that would be this one, 92.168.0.64, to LAN B. LAN B, once again, is down here on the bottom left of our network. This is LAN B right here. It includes up to that interface on that router, because once again, this is our default gateway. So assign the second subnet, that's our .64 network, to LAN B. Use the first host address for the customer router interface connected to LAN B. Can't use .64 because that's a network address. You have to add one to it. That's .65. That gives us 192.168.0.65. And we got to figure out what our subnet mask is. Once again, our subnet mask here is the same for all of these networks. We're using the second network here. Subnet mask is 255, 255, 255.192. It takes care of B1. B2, use the second host address. We use .65 up here for the router interface. Second one, .66 for the LAN B switch. Make sure to give it a default gateway. LAN B switch, the second one. Once again, we used .65 here. So we got to add one more to that, 192.168.0.66. The subnet mask stays the same for all these devices here. 255, 255, 255.192. And then the default gateway. Once again, we are looking at this switch right here. The default gateway is the exit on and off the network. That's this interface. It's this interface on the customer router. That's the gig 01 interface. We assign this IP address to that. So this is our default gateway for the LAN B switch. 192.168.0.65. It takes care of 2B. On the 2C, use the last host address for PCB. Make sure to assign the default gateway. Now, once again, this is the start address. This is the start of the third network. If you take one away from it, that's the last address in the second network. So 127 is the last address in that second network. But we can't use the last address because that's the broadcast address. So we need to take one away from 127. That gives us 126. The PCB address would be a .126 then. 192.168.0.126. Subnet mask, once again, is the same for all of our networking devices. What we subnetted there, 255.255.192. And then the default gateway. Over here, once again, our default gateway for LAN B is the exit on and off. That's this interface right here. That is our gig 01 interface. We assign this address to the gig 01 interface, 192.168.0.65. 192.168.0.65. That is our default gateway off of the network. We have all the fields filled in. I hope you're liking this episode on practical configuration examples. Leave a comment on what you think about these configuration examples. If you still have a question or comment, please let me know below. You can also visit my website at KevTechify.com for all of my details and how to get these episodes in video and podcast form. On the part 2, we are going to configure the devices. Configure basic settings on the PC, switches, and router. Refer to the routing table for device names and address information. Configure the customer router. Set the enable secret password on customer router to class 123. Now, once again, I'm going to click on customer router right here. Opens up our window. We're going to go into the command line interface. I make this window a little bit wider. We're looking for press return to get started. We got some other status updates, but I'm going to go ahead and hit enter once. It takes me in. Actually, I hit it a couple of times. To make changes, we have to go into privilege exec mode. To get into privilege exec mode, we type enable, hit enter. Notice our prompt changed from a greater than sign to the pound sign, the hashtag, or my personal favorite, the waffle sign. The waffle sign signifies we are in privilege exec mode. Now, set the enable secret password on the customer router to class 123. Enable secret. And then our password is capital C LASS 123. Oh, see what I did? I forgot to go into global configuration mode. Config T. Now I can go enable secret capital C LASS 123. There we go. That's something you need to be aware of, that you typed in the command, but you were in the wrong prompt. You were in the wrong mode. You need to change out there. That's what happened to me right there. Set the console login password to Cisco 123. Setting our console login. Once again, that's line con 0. Gets us into there. We then set our password. Our password of Cisco 123. Now we've set the password. Now we need to tell the login process on our line console interface to actually use it for the login process. All we have to do is type login at that point in time. We can exit out of our line con configuration. And notice right now our completion is going up. Right here, we're up to 13%. Configure the customer router host, or customer router as the host name for the router. Host name, I like tab completion, that's what I hit right there. Customer router. Once again, completion went up from 13 to 17%. Our name changed there successfully. Configure the G00 and the G01 interfaces with IP addresses, subnet mask, and then enable them. We are in global configuration mode, so we can go into interface G0/1, gig01, set the IP address. And I did G01. Right here is our information for G01. IP address of 192.168. Starting out address over 192.168.0.65. And then I hit enter. Notice it says incomplete command. Up arrow, space, question mark. What's it looking for? It's looking for the subnet mask. Our subnet mask, once again, is right here. So I go ahead and add that in at the end. 255 dot. Oh, I gotta fix the 255. There we go. And the last fourth octet is 192. There we go. And we have to enable it. We have to turn it on. Once again, the command to do that, turn it on, is no shutdown. There we go. Notice we get some updates here. Our change state has went to up for both of them, for the interface and for the line protocol. I'm going to hit enter a couple of times. Notice our completion is up to 30%. There we go. Now, we don't have to exit out. We can just change to the interface. Seeing as I just did gig 01, now we need to do gig 00. So I type in interface space G0/0. Our prompt, once again, still says we're configuring an interface. Our gig 00 interface right here has this IP address, 192.168.0.1, and the subnet mask of 255.255.255.192. IP address 192.168.0.1, and the subnet mask 255.255.255.192. There it is. Notice we are up to completion 39%. We need to enable it. We need to turn on that interface. Command, once again, is no space shutdown. Before I hit enter, we are at 39% completion. I hit enter. We are now up to 43% completion. I'm going to exit out, so I'm just in global configuration mode. That takes care of D. Save the running config to the startup configuration. That is done in privilege exec mode. I need to type out exit to leave global configuration mode. Gives me an update. I hit enter, give me some clear working space. Copy, run, tab. I hit tab so it types out running config for me. Start, tab. There we go. Copy running -config to startup -config. I hit enter. They want to confirm that's the file name I want. Yep, that's the file that during boot up is going to be loaded into memory, the configuration file. Go ahead and save that. We have now saved that information. Step 2, configure the 2 customer LAN switches. Configure the IP addresses on interface VLAN 1 on the 2 customer LAN switches. Make sure to configure the correct default gateway. I'm going to go ahead and close customer router. Go ahead and close customer router. And these are the 2 customer switches, LAN A, LAN B. I have to go in and configure. I'm going to go ahead and click on LAN A, slide it over, pull a little bit bigger, get on command line tab. Once again, we are at the press return to get started. Hit enter a couple times. Now we can go ahead and type enable, get us into privilege exec mode. First thing, configure an IP address on interface VLAN 1. Get into global configuration mode, config T. Then we want to get into the interface of VLAN 1, interface VLAN 1. Notice how our prompt changed from config for global configuration mode. Now we are configuring an interface. It has -if at the end. At this point in time, we can go ahead and enter in an IP address. IP address of, we can scroll up to our table. Once again, we are on LAN A switch. LAN A switch has an IP address of 192.168.0.2 with this subnet mask 255.255.255.192. 192.168.0.2. Once again, we use the second one, put in our subnet mask 255.255.255.192. There we go. Now, while we're in there, do no shutdown. Good habit to get into. Make sure that your device is on. Notice as soon as we did no shutdown, we got some status updates. Interface VLAN 1 went up. Line protocol has now changed up. Things are looking good. And the last part we had to do was set our IP, or set up our default gateway. To set our default gateway, that's a device-wide setting. It's not per interface, it's per device. And so what we have to do is get out of configuring the interface. I'd go ahead and type exit once. Pulls us back into global configuration mode. Then the command here is, because it's part of the IPv4 protocol, it's IP, and then default gateway. I hit D, E, F, and I hit tab. It completed it for me. And then I put in the IP address for the default gateway, 192.168.0.1. 192.168.0.1. Now, you don't have to enter in the subnet mask. The only time you enter in the subnet mask is when you are configuring, when you are setting an IP address on an interface. Because that IP address is already set on a different device, we're connecting to it. We don't have to put the subnet mask in there. At this point in time, before I hit enter, notice my completion's at 52%. I'm going to hit enter. Takes us up to 56%. I think that was all we had to do on that device. Configure the IP addresses for VLAN 1 on 2 customer switches. Make sure you get the default gateway. That's all we had to do there. I'm going to go ahead and close LAN A switch, open up LAN B switch, command line, make this line a little bit bigger. And we're going to go through and enter in the IP addresses. Scroll up to my table. Here's my IP addresses. Subnet mask again. From user exec mode to privilege exec mode, go ahead and type enable. Get into global configuration mode, config T. At this point in time, we now go into the interface of VLAN 1, interface space VLAN 1. Set the IP address, IP space address. Once again, our IP address here, 192.168.0.66, and our subnet mask. Because we are setting the IP address, we are setting it on interface VLAN 1, we do have to put the subnet mask in. IP address of 192.168.0.66 with the subnet mask of 255.255.255.192. Hit enter. Add some. Oh, I missed a 5 in there. Up arrow 1, left arrow over, make it 255. Hit enter. There we go. And turn it on. So do a no shutdown. You'll get some system updates saying things went good. And we have to set the IP address, or the default gateway. Once again, the default gateway is a device-wide setting. It's not per interface, so we type exit once to get out of configuring just an interface. Takes us out to global configuration mode. IP space DEF tab default gateway, and our default gateway was 192.168.0.65. 192.168.0.65. No subnet mask because we're not setting the address. We're connecting to an existing one already. Go ahead and set that up. Brings us up to 69% completion. Takes care of step 2. On to step 3. Configure the PC interfaces. Configure the IP addresses, subnet mask, and default gateway on PC A and PC B. Go ahead and minimize that. PC A over here. Once again, configuring the IP addresses on the desktop tab. IP configuration, I go ahead and click on that. I'm going to scroll up to my chart here to get my information. PCA information is right here, 192.168.0.62 for the IP address. 255.255.192 is the subnet mask, and the default gateway is 192.168.0.1. IP configuration right here is static. I go ahead, make sure it's on static, enter in my IP address 192.168.0.62. Subnet mask 255. It auto-populated 255.255.255.0, but once again, our default subnet mask ends in a .192. I need to go ahead and change that 192, and we have to put in our default gateway 192.168.0.1. That's this field right here, 192.168.0.1. Go ahead and minimize that window. We are up to 82%. The other thing I did here is make sure you click out of that field. As soon as you click out of the field, it commits the changes and your completion should go up to that. Right now I'm at 82%. Go ahead and minimize that. Open up PCB, click on desktop, IP configuration, make sure we're on the static here, enter in our IP address. Once again, looking at our chart, here's our IP address information. IP address 192.168.0.62. Sorry, wrong one. 192.168.0.126. Subnet mask auto fills out to the /24, but we're using a /26. We need to change the last octet to .192, and we need to fill in our default gateway 192.168.0.65. There we go. Now I still haven't clicked out of that field. Notice my completion's at 91%. As soon as I click out of that field, it takes me up to 95%. Coming down here, that is configuring our IP addresses. I'm not at 100%, so I'm going to go ahead and click on check results, click on assessment types. I am missing an IP address on LAN B VLAN 1. Oh, let's go in and check and see what I did. So on LAN B, my VLAN 1 IP address is wrong. On LAN B, our IP address. Now, best way to check this I found is go ahead and type out exit, bring us to privilege exec mode, and then do a show running -config. That's how our device is configured. That's the settings in RAM. At this point in time, I hit enter, I hit space. I'm going to go down to at the end of this, and here our VLAN 1 interface 192. Oh, I missed an 8 right there. I missed an 8. Because if we look here on our LAN, it's 192.168.66. I typed in 192.16, so I have to go in and change that. Now, to go in and change that, I'm in privilege exec mode now. I type in config T, go into the interface of VLAN 1, so interface VLAN 1. Now, to change an IP address, all you do is retype it and it's going to overwrite it. So IP address 192.168.0.66. Because we're setting the IP address, we need to put in the subnet mask 255.255.255.192. There we go. Before I hit enter, ooh, starting to get confused here. Before I hit enter, notice my completion's at 95%. I'm going to go ahead and enter. Takes me up to 100% completion at that point. Okay, that completes part 2. On to part 3. On to part 3, test and troubleshoot the network. In part 3, we're going to use ping command to test network connectivity. Determine if PCA can communicate with its default gateway. Do you get a reply? Determine if PCA. I'm going to go ahead and click on PCA. I'm going to close this IP configuration window, and I'm going to click on command prompt, because that's where we're going to run ping from. Determine if we can ping our default gateway. Now, I'm going to type in IPCON FIG IPconfig, all one word, hit enter. That's going to list out what my default gateway is. I could look it up in the chart. I could have scrolled up. I could go into the IP settings, but this gives me my IP address right there. Now, go ahead and ping our default gateway. Type in ping space 192.168.0.1. Yes, we get a reply. Determine if PCB can communicate with its default gateway. Okay, click on PCB. Once again, our IP configuration, if we look here, this is our default gateway, 192.168.0.65. So I'm going to close the IP configuration button here. I'm going to click on command prompt, because that's where we do our ping. Once again, if you want, the command here was IPconfig. It displays our information. Here's the same value for our default gateway, 192.168.0.65. PING space 192.168.0.65. Hey, look at that. That also works. Excellent. Last one. Determine if PCA can communicate with PCB. Do you get a reply? Okay, I'm going to open up PCA here. And they want to see, can I communicate with PCB? Scroll up to my chart. PCB's IP address is 192.168.0.126. PING space 192.168.0.126. There we go. Now notice our network portions are different. I'm pinging from 192. Let me scroll down to this chart here. I am pinging from this network to this network. They are technically different networks. What allows me to ping between them is going to my default gateway. The router routes between networks and then sends the information onto PCB, the destination. One network connected to a router that routes it to the second network. Determine if PCA can communicate with PCB. Did we get a reply? Yes. If you answered no to any of the preceding questions, then you should go back and check your IP address and subnet mask and ensure the default gateways have been set correctly. Part B, you want 3 yeses. If not, go back, figure out what you did wrong. That was Packet Tracer Lab 11.5.5 Subnet and IPv4 Network. It was my pleasure to provide you with this wonderful episode on configuration examples. If you like this episode and you got value out of it, please click that like button, give a 5-star rating, leave a comment. This all helps me bring you more great content. Please take a minute to subscribe to my channel. All my socials and contact information are on my website, KevTechify.com. There you can find out how to get all these episodes in video and podcast form. Thank you so much for watching this episode of my series on practical configuration examples for the CCNA. I've created 4 wonderful playlists for you on the CCNA. These episodes, I go through all the concepts that Cisco calls out for the CCNA. Once again, I'm Kevin. This is KevTechify. I'll see you next time for another great adventure.